Hello and welcome back. If you check our agenda, you will probably notice that the 4 next sessions are done by guys called Andreas. So I'm happy to introduce you the first one, Andreas Wick, our technical strategist, digitalization and IIoT. He will tell you how you can spice up your machine life with additional sensor data. Welcome, Andreas.
Thank you, Stefan. Yeah, so welcome from my side as well. Actually, it's my second session today, so I'm excited that I can be here again with you today. And this time I'm going to talk a little bit about how you may be able to spice up your machine's life with additional sensor data. So when talking about data, data is sourced in a machine most commonly by sensors and other devices like sensors or other data providers. And all this potential you have in your machine when you're now talking about setting up and implementing software applications are always or mostly a cooperation between sensor data providers and your platform and your software on the other hand. And if you think about the potential and if you have a look at the potential you have in your machine already, it may be a starting point for your application or for your applications to build up to. So first of all, I want just a few sentences about sensors themselves. And sensors are the data providers we have right now most commonly in machines. And there are two different kinds of sensor data providers you can think of. I've mentioned it before in the session as well. We have standard sensors that are measuring, for example, pressure or other physical data and is providing you then with an analog value. And if you're using a software to, if you want to use a software to analyze this data, it's pretty hard by doing so with analog values. So you need more clearer data for your application. So one thing to think about would be using devices that are more capable and more suited for IIoT related applications from the beginning. Or maybe you already have IO-Link architecture built into your machine, and as such you already have the potential for further software applications maybe, or for developing yours further. And just to give you a little bit of an example, IO-Link sensors are most likely providing you with already pre-processed data. So maybe you have already heard sessions about condition monitoring sensors, for example. They are providing you with pre-processed condition monitoring data like vibration, velocity, or peak-to-peak values and stuff like this. So, and if you're then thinking about next level analysis, it's of course way better to have data that is already clear and pre-processed rather than that you have to pre-process them manually. As an example, if you have an optical sensor which is providing you with a switching signal, this is, of course, it's very good because you can detect whether there is an object or not. But if you want to have a software solution or a cloud application that is using this value to measure over a very, very long period of time whether your belts are running in the correct order, whether the speed of your wheels are correct in the correct timing and stuff like this. These are all tasks that are very high frequent, so that you have a lot of switching points per minute, most likely. And with a cloud application, you cannot pull sensor data every 10 milliseconds. So that's just not what an application running in your network, running in the IT, is most likely suited for. And as such, it is possible, for example, as an example with this optical sensor, if you're pre-processing data and the sensor is providing you already with a parts per minute or switching points per minute value, that is highly likely to be more valuable for your application because you can use this value directly. And it doesn't matter whether you pull this information once per minute, once per hour or stuff like this, because you don't have to calculate the parts per minute, you just ask your device for it. And so such as goes for parameter data. So additional data you get from the sensor. So most likely you know parameter data, for example, from setting up switching points, so that you don't have to run to your sensor with a small screwdriver and set up your switching point. So that's what you most likely have to do with traditional standard sensors. But you can set parameters here. But parameters I want to talk about is most likely the parameters the sensor is providing you for reading. So this means, for example, additional data like internal device temperatures, operating hours, boot cycle counters, excess gain values, raw data values that you can use for further analysis. So all this kind of data is what I mean by when I'm talking about using additional service data for analysis. I give you an example in a minute. And you can use this, for example, also, of course, for diagnosis. And all the metadata you can also use. So if you think, for example, about your pictures in your picture library in your home PC, you have behind each picture lots of metadata, and that's also additional data you're going to use. Most likely not very clearly that you're going to use this, but your computer is using it. For example, to order it by the correct creation time, or to put it in the correct place on a map or stuff like this. So that's all metadata that is going to be used. Same goes for sensors and sensor metadata, like device identification data, firmware versions of the sensor, hardware versions of the sensor. So you can, for example, build up asset management systems that are telling you whether you have plugged in the correct sensor at the correct machine, and you don't have to program this in a PLC. You can do this in IT applications. And of course, the general benefit, one sensor, one data point with a standard sensor, and one sensor and many data points with, for example, an IO-Link sensor. And when we're talking about, I talked earlier about that you don't have to do it in the PLC. The PLC is made up or is programmed and created for handling process data, cyclic data that is refreshed on a very, very high rate. It needs to be very reliant in all these kinds of things. But what is a little bit a harder task to do, or not so easy for the programmer to build into a PLC, is handling the analysis of service data, of this additional data. And this is most likely because this data is going to be asked for acyclically, so not on a cyclic basis. And a PLC is not very well suited to do this. And also some values that you want to monitor may divert from the regular value, not in terms of minutes or hours, but in terms of days, weeks, or months. And you have to store this data, you have to process this data and all stuff like this. And if you're going to process this data, for example, in the next level application, in an IT application, you can do many different things with this kind of data. So for example, you can think of two things. One thing would be to monitor your surrounding, the surrounding of your machine, by using these additional data. So for example, if you're thinking about the temperature value of a sensor, internal temperature value, and you have different sensors in your machine, and one of these values is rising, then most likely a problem with the sensor occurs. But if all of your sensors are detecting the same temperature rise, you may not need a dedicated temperature sensor to measure that you have a diversion in your internal machine temperature range. And as well goes, for example, for the use of current data. So the current consumption of, for example, if you have a power supply which is providing you with its current consumption. You can detect whether, for example, over days or months, your motor is going to, or your engine is using more current and more power. And this could lead to the knowledge that you may need to maintain your couplings or stuff like this. So this all thought experiments you can do here. The other thing you could do is doing self-awareness. So, for example, with boot cycle counters or operation hours. But best thing here would be that I show you a little bit with a little bit hands-on graphics what I mean by when I'm talking about these values and how they are going to look like. So we have our cube here where we have packed some different kinds of sensors. We have packed standard IO-Link switching sensors, like the one I talked before about, which would be the one with the internal counter, distance sensors. We have a power supply with IO-Link lights and stuff like this. And I will just show you, I just turn on the light, and in a minute we will see something that I will want to show you. But first, as an example, for a self-awareness application or for application for your surrounding would be when we're talking about a standard switching optical sensor. So first thing would be, why would I use this additional data here? But we have a reflective sensor here. And wouldn't it be nice to know whether your reflector is going to get dirty or whether it was moved a little bit? Because, for example, in tire manufacturing, you can think about you have a very dirty environment, and your reflector may degenerate over time or may get dirty over time. Or it is your lens that is going to get dirty. And I can just simulate this here. If I move a little bit the reflector here to change the value, you will see in a minute that the light value that is being recognized by the sensor is going to be reduced, as you can see here. Of course, this will not happen normally in a short period of time, but in a dirty environment, you can expect this to happen over weeks, over months. And if this is happening, and if you're over a specific value, your sensor is going to switch constantly or switched off constantly. So you have a failure in your machine, and you first have to look what the hell is happening actually right now. And then you have to search for the problem. Here you can set limits, for example, to monitor this light remission value and to check whether your lens is going to get dirty and to maintain it before you have a faulty sensor status. Same goes, for example, for a standard inductive sensor. Same here, but not with optical dirtiness, more likely with inductive dirtiness. So if you have, for example, parts of metal that is stuck on your surface of the sensor, and if you have a standard switching sensor which is giving you as an output its physical measurement value, so it's not like a scaled or linearized value, it's just a indice for you to check whether your lens is or your value is different than it actually should like when your sensor is clean. So stuff like this. Also, for example, you have operating hours where you can check maintenance times, and you don't have to track them in a database. Stuff like this you can ask them directly from the sensor, because then you also get the correct times of the how long the sensor was switched on. And as you can see here right now with the internal device temperature, you see already I switched on the light a few minutes ago, and you can see that the temperature, the internal device temperature, is raising. And this is just an example on how such a deviation can look like. Of course, this time it is normal, but for example, if you don't know whether some of the lights here are fine or not, if the lights are not working but the sensor itself is working, you can see that the temperatures, for example, will not rise, but the sensor should actually be switched on. So that's a conclusion you can do by fitting those two values together. And that's just an example of what you can do with all this data, and that's just a few of the sensors. Of course, most likely you will not use all of them, but maybe you get some ideas on what you can do with this additional sensor data. So it's up to your imagination a little bit. Thank you very much. And yeah.
Thank you, Andreas, for this great demonstration and for these insights. So let's have a look if someone wants to ask you something from the audience. Right now there is no question, but I would like to ask you something. How does it look like with the sensor data? Yeah, we see the sensors and we see the dashboard, but where is this data processed?
Yeah, that's something I didn't figure, or I didn't point it out that much. I talked about that PLC is not very well suited for monitoring this kind of data over a long period of time. So this, for example, here is also done in the IT system. So we also have here a gateway running in this cube, and we are pulling the data parallel to a PLC directly from the web server of the master. So if you have a PLC running and it's doing all its tasks, you don't have to worry that you need something extra. You can still use the same master for pulling the data parallel to your PLC. And this is done by an API that is running on the IO-Link master. And in this case, also we are using a Raspberry Pi as a gateway and open source software for pulling the data and also for visualizing them.
Okay, so if I have an existing application, I have my sensors installed and everything, is it possible to retrofit or to upgrade my existing application with something like that?
Yeah, so it's depending a little bit on your setup right now. So for example, if you're already using devices that are providing you with interfaces or with IT interfaces, like such an IO-Link master, you can retrofit them because you don't need to fiddle with your PLC. So that's also a very important point here. You don't need to fiddle with your PLC. Your PLC programmer does not need to do anything extra. You can do this parallel to the PLC just by pulling the data directly from the field devices themselves. So that's actually a good thing, because you don't PLC. If you would need to implement it into PLC, it's of course way harder to program it and to implement it and to make it safe.
Okay, perfect. Thank you, Andreas, for this interesting session, and we will have the pleasure again to meet just after our break that we will have now. We will be back at 3:45. Thank you all for listening, and see you later.